All right, this is actually the second page of worksheet 3 because I want to go through an example problem, and I want you to write it down very carefully as I go through it because I found that's the easiest way to explain this worksheet since it's a relatively long calculation. But first of all, I want to talk about the sort of conceptual part behind this, which is actually written on the first page of the worksheet, so you can refer to that as I'm talking. On worksheet 2, we learned how to calculate a simplest formula, which we said was a ratio, right? H2O means for every 2 hydrogens, you have 1 oxygen. And for an ionic compound made of a metal and a nonmetal, like NaCl or MgCl2, the simplest formula is usually it. That's the only true representation of the combination of sodium and chlorine, for example, in NaCl, or magnesium and chlorine in MgCl2. But in covalent compounds, where you have 2 nonmetals, there are often multiple formulas that are multiples of each other that represent molecules that truly exist. So, for example, there is a molecule where for every 1 carbon you have 1 hydrogen, CH. But there's also a molecule in existence where for every 2 carbons you have 2 hydrogens. So what did we do? We took CH, which is a simplest, reduced, fully simplified formula, and we multiplied that whole formula by 2. And that's how we get to the C2H2. So in this case, the CH is the simplest or most reduced formula, and the CH2 is the molecular formula. It's a whole number multiple. Okay, another example. There is a molecule where for every 1 carbon there are 2 hydrogens. Okay, but there's another molecule that exists where for every 3 carbons there are 6 hydrogens. The C3H6 is a multiple of the simplest formula CH2. Right? If you take CH2 and you multiply it by 3, you get C3H6. So that C3H6 is what we would call a multiple, or the molecular formula of the CH2. All right, so let's get to our example problem here. What they want you to do here is calculate first the simplest formula and then the molecular formula for a hydrocarbon, meaning a compound made of some amount of carbon and hydrogen. And they're telling us, just like they did in worksheet 2, the percent of carbon and the percent of hydrogen. So, step A is exactly what you did on worksheet 2. Just what you did on worksheet 2. You know how to do this already, okay? The 84.09% carbon turns right into grams, and the 15.91% hydrogen turns right into grams, because we're going to assume we have a 100-gram sample. All right? But remember that formulas are mole ratios, not gram ratios. So we're going to take the grams and convert them into moles. So if I want to know the number of moles of carbon, and I know that I have 84.09 grams of carbon, I'm going to set up a factor label. Periodic table tells me that there are 12.01 grams of carbon in 1 mole of carbon. Cancel out my grams, do my division, and I'm going to leave quite a few decimal places, like we did in worksheet 2. 7.00167 moles of carbon. Okay, I'm going to do the same thing for hydrogen. If I want to know the number of moles of hydrogen that are equal to 15.91 grams of hydrogen, I look at the periodic table, there's 1.01 grams of hydrogen for every 1 mole of hydrogen. Factor label lets me cancel out my grams of hydrogen. I do my division problem, and again I'm going to leave quite a few decimal places. 15.75248, moles of hydrogen, not grams, moles. Okay. Now, I need to start making this look like a formula, not just a bunch of numbers. So, I'm going to write my moles as little subscripts like they were a formula. So for carbon, I have 7.00167 moles, and for hydrogen, I have 15.75248 moles. The 7.00167 is definitely my smaller of the two numbers. So I divide both sides by that number. Okay, so I have two division problems. Now, 7.00167 divided by itself gives me 1. Okay, but for the hydrogen, when I do the 15.75248 divided by 7.00167, I get 2.249 something. And that's not close enough to round all the way down to 2. And it's certainly not close enough to round all the way up to 3. So the best I can do is round it to 2.25. So remember in worksheet 2, you cannot leave this as a decimal, all right? You got to think, what could I multiply 2.25 by to give me a whole number? And we're going to think of that 0.25 like a quarter, 25 cents, right? How many quarters does it take to equal $1? 4. So that's your clue that you need to multiply by 4. And not just the hydrogen, the whole thing's got to get multiplied by 4. So you get C4H9. And that's your simplest formula. So far, all we've done is the same as what you did in worksheet 2. All right, step B asks you what is the mass of the simplest formula. So, in other words, how much does C4H9 weigh? Well, you've got 4 carbons. According to the periodic table, each carbon weighs 12.01. Multiply by 4, you get 48.04. And you've got 9 hydrogens. According to the periodic table, each hydrogen weighs 1.01. So you've got 9.09. You add these numbers together, and you get 57.13 grams per mole. And I'm just going to reiterate here, that is the weight of a simplest formula. That's how much that C4H9 weighs. Okay, that's your answer to B. Now, at the end of the day, what we really want to figure out here is not the simplest formula or how much the simplest formula weighs, but we want to know what the molecular formula is. So, in other words, we need to figure out what we're going to multiply C4H9 by to get this larger formula, this molecular formula. So in part C, they're always going to give you an additional piece of information. They're going to say, we don't know what that bigger formula is, but we know how much it weighs. So in this case, it weighs 114.24. And here's what you're going to do. You're going to compare the weight of the bigger formula, the molecular formula, with the weight of the simplest formula, that one you just calculated. So I would write this down because you're always going to do this same little division problem. In part C, you're going to do the molecular formula weight, okay, and that's going to be given in part C. Okay, so like in this case, it was the 114.24. And you're going to divide by the simplest formula weight. Okay, and that's part B, right? In other words, right here, what you just calculated. So in this problem, that's 57.13. So when you do that division, you get, I don't know, 1.9996, which we can round, say that's close enough to 2. So that means the molecular formula weighs twice as much as the simplest formula. In other words, it's twice as big. So we take the simplest formula from part A, the C4H9, and we multiply it by that number 2. So we get C8, H18. That is your molecular formula. That's really what this whole big process has been all about. So, this worksheet has a lot of steps. You need to be very organized and methodical. Always do the same steps in the same order. And probably, for the first couple, you're going to need to refer back to this example problem. So I hope you took good notes, and we will practice when you get to class.